All right, section 4.4, prove triangles congruent by SAS and HL, day 1. So first, we're going to talk about an included angle. That's an angle between two sides. So if you have, let's draw my triangle like this. My two green sides, and then that red angle is an included angle. It is between those two sides, included in those two sides. So that's going to allow us to be able to do this next definition, side angle side, or the SAS congruence postulate. And that is, if two sides and the included angle of two triangles are congruent, then the triangles are congruent. So if I'm able to get myself some more room, we will doesn't want me to scroll down. Okay. Then I guess we won't scroll down. I will draw it off to the side here. So that would be, if we've got our triangle, and I'll use some different colors. All right, if I know those angles are congruent, and I know these two sides are congruent, then I can prove those triangles congruent by the side angle side congruence postulate. So that's what an included angle would look like. It's in between those two sides that are marked congruent. It cannot be either of those other two angles. Those would not be between those two congruent sides. And so just because those blue sides are marked the same color, without that angle there, I wouldn't know that they're congruent. But because we do have that angle marked congruent, then I would know that the blue sides are also congruent. So it's the side angle side. Starting at one side, say the green side, then you come to an angle, then you go up the red side. Start at the green side on the right triangle, come to an angle that's congruent, and then go up the next side that's congruent. It's your side angle side. Then the HL congruence theorem is the hypotenuse leg. If the hypotenuse and a leg of two right triangles are congruent, then the triangles are congruent. So this is specifically for right triangles. So if I've got two right triangles, we know they're right because they're marked as right angles. If I know the hypotenuse, your hypotenuse is the side that is opposite the right angle. So it's not touching the right angle at any spot. That's called your hypotenuse. And then the other two sides are your legs. So if your hypotenuse and one of your legs are congruent on a right triangle, then your triangles are congruent. So it could have been that bottom side that were congruent or that left side that were congruent. But I need to see that the hypotenuse and the leg. So let's name the included angle between the given sides. So number one, we have side CB and side BA. The included angle would be angle B. Then we have side CD and side CA. So our included angle would be right there. But we have to use 3 letters to name this angle, because it's at the vertice C, there are 2 possible angles, actually 3 possible angles that we could be talking about when we say angle C. So we've got to use 3 letters to name it, and we want to start on one of the ends. C, our included angle, or our included spot, needs to be in the middle. So I would say A, C, D. All right, then we have BA and AD. So again, we need to use 3 letters because there are multiple angles we could be talking about when we're talking about the vertice A. We could talk about either of those smaller angles or this big angle that we're looking at. So I would call it BAD. And then the fourth one, CA and AD. And then we need that included angle, would be angle CAD. So all of these, 2, 3, and 4, must use 3 letters. Your answer would be incorrect if you only said angle C for number 2, or angle A for number 3, or angle A for number 4. It would be wrong. You have to use the 3 letters for those 3 examples. Again, number 1 only needs to be 1 letter because B is all by itself out here. There's no other line going to that vertice to split it up into separate angles. It's just 1 angle up there. All right, here we need to decide whether enough information is given to prove that the triangles are congruent using the side, angle, side congruence postulates. We're looking for side, angle, side specifically. So number 1, we've got triangle PQT. So P to Q to T, and then back up to P. And then we've got RQS. R to Q, Q to S, and S back up to R. And we can see our congruent marks there and there. Those blue sides are congruent, the green sides are congruent, and we also have our congruent angles. So we need to look at, is this side, angle, side? We do have 2 sides and we do have an angle, but we need to make sure that angle is between the 2 sides. So if I'm looking at the green line, following the green line, I start at T, that's a side, I come to an angle, and then I go up my other side. So that is side, angle, side. So yes, that's provable by side, angle, side. Then number 2, we have NKJ. So from N to K, K to J, and J to N. And then I have L to K, K to M, and M to L, I see my congruent marks on my green lines, or my green sides. Congruent marks on my red sides. Now, is there an angle? Are there two angles that are congruent? Hopefully you spotted that these are vertical angles. So those are congruent. So then we need to look at our sides. Starting on the left triangle at the red side, we have the red sides congruent, which comes up to the angle, and then goes up the green side, which is congruent. And then on the triangle on the right, we start on the red side, which is congruent, go to the angle, and then the green side, which is congruent. So they're all adjacent, one after the other, side, then an angle, then a side, and they're all congruent. So yes, this is provable by side, angle, side also. Then number 3, we have WX. Then to XY, from X to Y, and then from Y to W. Then Z to X, X to Y. It's following that red line still. And Y to Z. So our WY and YZ are both congruent and marked that way. Our red line is a shared side, so we can mark that congruent. And then we have two angles that are marked as congruent. So first look at our left triangle. We go from the green side to the blue angle and then up the red side. So that would be in the right order for side, angle, side. But then if we look at the right triangle, the triangle on the right-hand side, our green side is not touching that blue angle at all. So that angle, that congruent angle, is in a different position on this other triangle. So these are not provable by side, angle, side. If you start at that green side, like we did on the triangle on the left, you would go side, side, angle. Or if you started with the angle, which you shouldn't start with the angle, in this case, I'm trying to prove side, angle, side, it'd be ASS, and that would be bad. We don't spell ASS. So that is no. Angle is not in the middle. So no, angle is not in the middle. That is not provable by side, angle, side. All right, here we've got a bunch of different examples. We need to prove them by any of the methods we've used so far. So side, 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 angle, side, or hypotenuse leg. And if none, write none. So our first one, we have side, an angle, and side congruent with a side, angle, and side. So that is side, angle, side. On our second one, B, we have a side, then to an angle, and those sides would be congruent as well. And the top triangle, we have a side, an angle, and then our congruent sides in the middle. So that is also side, angle, side. Letter C, we just have three angles. Remember, three angles does not prove triangles congruent. So this is none. We need three sides to prove triangles congruent, or side, angle, side, or HL so far, but three angles doesn't do it. Letter D, we have a right angle. That's actually a right angle there, making that little square. So we know we're dealing with two right triangles. So we have two right triangles that share this side, which is one of their legs, because we're trying to see, since it's a right triangle, see if HL works. These sides out here would be the hypotenuse. Remember, the hypotenuse is opposite your right angle. So this is hypotenuse congruent and legs, and at least one leg congruent to the other triangle. So this is HL. Then letter E, we have these two sides are congruent. These two sides are congruent, and we have vertical angles in the middle. So going from green to the blue angle to the red side, on both sides, left and right, this is side angle side. Then letter F, we have a shared side here in the middle. Two sides out here in green. And then an angle over here on the right. So we've got to go, since we've got two sides and an angle, it's got to be side angle side. It cannot go side side angle or angle side side. That angle has to be in between the two sides. And this is not in between or not included in those two sides. So this is none. The letter G, we have a shared side here in the middle. Two congruent sides opposite each other there in blue. Two congruent sides opposite each other here in red. So yes, side, side, side. These are congruent triangles, side, 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 three sides. All right, letter H. We have congruent sides there. Congruent sides on top and bottom. Vertical angles. But we also have, and if we stopped there, that would be ASS, that wouldn't be enough. But we do see these arrows showing us that these lines are parallel. So if those lines are parallel, we can show that those angles are congruent because of alternate interior angles. Those are alternate interior angles. Imagine this extending out, and these are your two parallel lines. So we've got alternate interior angles here. So that's congruent by side angle side. And yeah, alternate interior angles would have shown on the other side as well, but that wouldn't have given us side angle side since we had just those two sides that were marked congruent, two sets of sides marked congruent. And then we have letter I. Since they're right triangles, we're going to try and prove it by HL first. We do see that those are congruent. I guess I only needed to put two, but I put three. And our two down here are congruent. The hypotenuse, the two hypotenuse are not congruent. So HL wouldn't be a reason here. However, we still have right angle here, right angle here. We know right angles are congruent with one another. And from the green side to the right angle to the blue side, that's side angle side. So it's still provable by side angle side. So just because it's a right triangle doesn't mean it has to be HL. But HL does prove some right triangles congruent that otherwise would not be able to be proven congruent. Right, so that is it on your notes. Make sure to do the 4.3 or 4.4 day 1 homework.